Data visualizations are not just an automatic visual encoding of data points. When you design something with data, you need to make a lot of different design choices that will affect the final result. In this lesson, you will learn 4 good practices or tips to guide you in the process of data visualization design. They do not have to be taken as absolute rules, but rather as a critical aspects of the process you need to take into consideration when you design a data visualization. The 4 good practices are related to building visual hierarchies using all the elements of the layout, enriching a visualization with the help of textual and graphical annotations, designing legends that really help users to decode the visualization, and choosing colors wisely and in an inclusive way. Data visualizations are not isolated objects, but they are always placed inside a specific container, such as a web page or a newspaper spread, the page of a book, and so on. In each of these formats, you have different visual elements that you need to take care of. Indeed, designing a visualization of data means making choices about the arrangement of all the visual elements of the page. Some of the visual elements to take care of in the design of data visualizations are a title and a subtitle, description text, textual annotations, labels, axes, a legend. All these elements can help the reader to engage with the visualization. It's important to use them together with the visualization itself to design output that are not flat but characterized by a visual hierarchy. In cartography, a visual hierarchy refers to the presentation of features in a way that implies relative importance. Visual hierarchy is a good strategy to create entry points into a data visualization. If I show you a visualization containing only visual markers, it's not really understandable. Visual entry points helps users to approach the visualization and stimulate them to explore it without being overwhelmed by the complexity of data. Adding such entry point would help our visualization, adding titles and axis names. Now it's more readable. We know the topic, its framing, and the axis. But still, we don't know the meaning of sizes and colors. One of the most common errors is to forget to put a legend in the visualization. A legend or map key is a graphical and textual element that describes how to interpret color and symbols used in the visualization. Well-designed legends make the process of decoding a visualization easier for the user. In general, each visual variable used in the visualization needs to be explained in the legend. Size of items and their scale, color schemes and textures, the position of the elements. All these variables need to be explained. At the same time, you should try to keep your legend small, synthetic, and easy to read. Legends that are too big and complex require too much cognitive effort and make heavier the process of understanding a visualization rather than making it easier. If your legend is too long and complex, it could also mean that you have used too many visual variables in your visualization, and you may want to consider to reduce the amount of data visualized. Another way to engage users with your visualizations is to enrich them with textual and graphical annotations. They provide context to the data and add depth and richness to the insights user can have with the visualization. We can think to annotations as an additional interpretative layer that the designer can add on the top of the simple visual encoding of the data. They are usually added as a last step in the process. For example, In our graph, it can be used to highlight the most relevant items. In the same way, in a trend line showing data over time, the highest peak can be annotated with sentences about the events that sparked the rise of the data. Or, in a network graph, clusters of similar closer nodes can be highlighted with a circle and described with a short text. Colors are also very important, and therefore they must be chosen carefully. In particular, you need to choose colors according to the type of data you have. There are mainly two types of color schemes, categorical and sequential. Choose categorical color schemes to encode discrete data values. For example, a list of countries or a group of people divided by the color of their eyes. When you choose color for a categorical scheme, be sure that colors used are different enough from each other, so to avoid confusion. Instead, choose sequential color schemes to encode quantitative data, characterized by increasing numerical values. For example, you can use sequential color schemes to visualize temperature records in a given city over a year, or the voter turnout of different cities during one election. Online, there are many available tools to choose a color palette. An old but good tool is Color Brewer. In addition to choosing the right color scheme according to the right type of data, when choosing colors, try to adopt an inclusive approach. Remember, for example, that 8% of men and 0.4% of women experience color deficiency. Look at this chart. In the center, you can see the color range for a normal vision, while at the four corners you can see simulations of what people affected by color blindness see. So, choose your color, having in mind also the needs of people with color vision deficiencies by adopting a color-blind safe palette. In conclusion, in this lesson we have described four important strategies to design effective data visualization: building visual hierarchies using all the elements of the layout, enriching a visualization with the help of textual and graphical annotations, designing legends that really helps users to decode the visualization, and choosing colors wisely and in an inclusive way. Do not take them as a mantra, but keep in mind that layout, annotations, legends, and colors are critical aspects of data visualization design.